All right, guys, happy Tuesday. Today we're going to be talking about surface areas of prisms and cylinders. So a surface area of a solid is just what the phrase says. It's the area of the surface of the solid. So it's the sum of the areas of all of the faces of a solid. So sometimes it's helpful to make a net of a prism, and that's kind of by like unfolding it. So you'd have this front side would be those 2 by 6 squares, and then the top is here. One of the sides is there. Keep folding it around. You'd have the other back side and the bottom, and then the back right top side kind of there. Okay, so I've been saying the word prism a lot. A prism, by the way, is a polyhedron, so that means no curved sides with two congruent parallel faces called bases. The other faces are the lateral faces. So the two ones that are parallel are the bases, the others are the lateral faces. And you name a prism by its base. So if it's two parallel pentagons, that would be a pentagonal prism. If it's triangles, it's a triangular prism. If it's a rectangle, it's a rectangular prism. So whatever the bases are is what you use. Now to find well, I won't go into that yet. We'll just look at these definitions. So an altitude of a prism is a perpendicular segment that joins the plane of the bases. So, if you're looking at this is the altitude or the height. So a prism may either be right or oblique. It's right if the angle between the two bases are a right angle. It's oblique if the line drawn between the two parallel bases is not a right angle. So these would be two oblique prisms. These would be two right prisms, even though this one's kind of on its side. So, this right side and left side would be the bases on that prism. Okay, the lateral area of a prism is the sum of the areas of the lateral faces. So not the bases, but the other sides, that's the lateral area. The surface area is all of the areas, so the bases and the lateral areas. Okay, so let's get into what you're going to be doing. It's going to ask you to find the surface area of prisms, and there's a couple of ways you can do it. You can draw out a net if you want. Or you can kind of draw out, there are some formulas for some of them. So we'll try the net method first. So this takes a little bit of skill with the drawing. With a rectangular prism, so it's going to be, you've got your top, you've got your, the big front side. So we've got the top covered, we've got the front side covered, and then we'd have the two sides. And then we'd have the bottom and then the back of the prism. So that's what a rectangular prism net would look like. So for the top, what is the length and width of the top? That would be 3 by 4, right? And then for the sides, that would be, this is a length of 5. And then how wide is this? Also 3. And then again, we've got another top, so it's a length of 3. We've got another back side, so it'd be a length of 5. And then this, of course, is 4. So this can be kind of confusing. So I don't really like to do the net because it's like, I don't know, I get kind of confused on what part of the prism I'm looking at. So what I usually do is I just find the area of the top and the bottom, the front and the back, and then the two sides, and then I just add them all together. That's what I do. So looking at the top, which is the same as the bottom, top and bottom is 3 times 4. So they would both be 12. The front So I'm looking at the front of this prism, it's 4 by 5. So that would be 20, which means the back would also be 20. And then the sides are going to be these two pieces. So that'd be 3 by 5. So that's 15 for both the sides. Then we just have to add up all of this. So we've got 40, we've got 24, and we've got 30. So we've got 70 and 24, which makes an area of 94. And it is an area, so your units is squared. So that'd be 94 square centimeters. Okay, so there's a formula that you can use instead of drawing out a net. So that formula for any, and it has to be a right prism, is the surface area is 2 times the base plus the perimeter times the height. So that formula makes it a lot quicker to find any right prism. Okay, so we're looking at this one. This is a rectangular prism, so you find the area of one of the bases, one of the two parallel sides, one of the two triangles. So remember, triangle is, so area of a triangle is base times height divided by 2. So in this triangle, it would be 3 times 4 is 12, 12 divided by 2 is 6. Okay, so that's the base. Now we also need to know the perimeter of the base and then the height. So the height is right there, it's given to us. The perimeter, we have 2 of the sides, we're missing that third side. So, you know, if you did Pythagorean theorem, I know that this is a 3, 4, that has to be 5 if you do the Pythagorean theorem, because 16 plus 9 is 25, square root of 25 is 5. So the perimeter is going to be 9 plus 3 is 12. The height is 6. So now I have everything I need to plug into my formula. It is 2 times the area of the base plus the perimeter times the height. So the base is 6, the perimeter is 12, the height is 6. So that would be 12 plus 72. That would be a surface area of 84 square centimeters. All right, this next one. Okay, we've got ourselves a hexagon in there. So we have to find the area of that hexagon. That's going to be the toughest part. The other things are kind of given to us. The perimeter of the hexagon, it's a regular hexagon, so there are 6 sides of 6. That's perimeter of 6. The height is also given to us as 12. But the area is a little bit tougher. So it's a regular hexagon, so you should remember from the last chapter that the area is 1/2 the perimeter times the apothem. So what we need to know is the apothem, right? We have the perimeter already. So I will draw a hexagon over here and we'll go through that again like we did last chapter. Hexagon. Okay. So remember, we have to make that central angle, but really we're going to cut that central angle in half. So we're looking at a side length of 3 because that's half of 6. And remember, this is the apothem right here. So 360 divided by 6 would be 60. If we cut that in half for that apothem, it would be a 30-degree angle. So this is a 30, 60, 90 triangle. To get from the short leg to the long leg, you multiply by the square root of 3. So the apothem is 3 square roots of 3. So I plug that into my area formula, and that's going to be 1/2 the perimeter times the apothem. Half of 36 is 18. 18 times 3 is 54. So my area is going to be 54 square roots of 3. Okay, so I've got everything I need. Now I'm just going to plug it in to the formula. So surface area is 2 bases plus, not 2, perimeter times the height. Plug it in. 2 times 54 square roots of 3 plus the perimeter times the height, 36 times 12. Okay, so that would be 108 square roots of 3 plus 36 times 12. is 432. So that's an exact answer. If they want a 2 decimal approximation, you would type that into your calculator. 108 square roots of 3. Make sure you close that parenthesis. Plus 432. That would be about 619.06 square meters. Okay. Now we're going to move on a little bit to cylinders. A cylinder is a solid that has two congruent parallel bases that are circles. So the altitude is the perpendicular distance that joins the two bases, and the height would be the length of that altitude. So again, you can have right cylinders where the bases are directly over each other, or you can have oblique cylinders where it's not going to be that right angle. So it has a formula as well. So it uses the lateral area, which is, so you imagine unrolling the side of the cylinder and flattening that out, it would make this rectangle. The lateral area is 2 pi r, which is the circumference, also known as the perimeter of a circle, times the height. So that's really the same. And then plus the two areas of the bases, which in this case the bases is pi r squared. So that formula still works. It's just a little bit different because it's going to have some pi's in it because you're dealing with circles. So it's really 2 bases plus 2 times the perimeter times the height, but the perimeter is a circumference, so they say it's 2 pi r. So the formula that you'll want to write down and have handy is, for a cylinder, it's 2 pi r squared plus 2 pi r h, where r is the radius and h is the height of the cylinder. Okay, so here's a couple of examples for that, and then we'll call it a day. The radius of the base of a cylinder is 4 inches, and its height is 6 inches. What is the surface area in terms of pi? Okay, so I'm going to write down the formula, and then all I have to do is plug it in because it's spelled out for us pretty nice. 2 pi r squared plus 2 pi r h. So that'd be 2 pi times the radius. The radius, they tell us, is 4. And 2 times pi times the radius, which again is 4, times the height, which is 6. Okay, so simplifying, 4 squared is 16. 16 times 2 is 32. So that would be 32 pi. And 4 times 6 is 24. 24 times 2 is 48. So that would be 48 pi. 32 pi plus 48 pi is going to be 80 pi. And it says to leave it in terms of pi, so that would be the surface area. It is square inches. All right, here's a cool aquarium. It is in Berlin, I guess. It's called the Aquadom. It is 82 feet tall, has a radius of 11 feet. It's the world's largest cylindrical fish tank. Find the surface of this area without the area of the top base, because it's a fish tank. You know, the top would probably be open, so that's why they're saying find the surface area without the top, because there's probably not a surface up there. All right, it says find the exact surface area, and then also plug in pi to be 3.14 to approximate that surface area. Okay, so if we're finding it without a top, our formula normally is 2 pi r squared plus 2 pi r h. Well, there's not a top on it anymore, so we're going to not be using that 2 because there's not 2 tops and bottoms. There's just the bottom on this one. So it's going to be pi r squared plus 2 pi r h. So again, we just got to plug in the numbers they give us. They say the radius is 11. And the height is 82. So that would be 121 pi. And let's see, let's type that one in. 11 times 82 times 2. 1,804 pi. Add those together, and that would be 1925 pi. So there's the exact surface area, and then it says to use 3.14, so not the pi button. So 1925 times 3.14, 6,044.5. Okay, so, just a lot of formulas today. Plug it in, and if you need any help finding the areas of some regular polygons on my math lab, let me know. Good luck. Have a good time. We'll talk to you later.